Hello class, this is a video tutorial on annuity as a recurrence relation. Recall that an annuity has the repeating interest increase and that repeating deposit or repayment. Also recall that the end balance of 1 year becomes the input for the calculation of the next year. So here's 1 year, we start on 0, find 0.5%, add that on, add the deposit, and that becomes our end result. This end result then goes back to the beginning and we run the same calculation over and over again. This end result goes back, then we repeat that calculation. As you can see, this is indeed a recurrence relation. Notice how we can describe this as starting on 0, we increase by 0.5%, and then we add the $500, and then we keep going over and over again. So a small change I'd like to add here, whenever we increase by a percentage, remember that we can just do we can multiply by the 100% plus the percentage we're looking for. Okay. So the small change, instead of finding this 0.005, we can just go 1.005 and multiply by that to find the increased amount. With that in mind, can you see how this recurrence relation, this annuity, can be seen as this? And I'll demonstrate to you how it can work. You can check your calculator here. I've already done a few. Starting on 0, we are multiplying by 1.005 and then adding 500. Here's the first calculation. The value of the previous year becomes the input. We get the results. That becomes the input. And then we get the results. You can check using your calculators. This is what we are calculating. Here's another example. In this case, we are looking at a loan instead. So because it is a loan, we're starting with $5,000. When we're charged 5%, remember we can just make this 1.05 to find the increased amount. And since this is a repayment, instead of adding this, we're going to be subtracting. We get this result. And once again, notice how this result goes back to the beginning and we keep repeating that calculation. So describing this, starting at 5,000, increase by 5%, subtract by this amount. And here we have the recurrence relation. If you really would like to see it in action, I've prepared it here. You can check using a calculator. You can put $5,000 in. Your first answer will most definitely be that one there, 3840. We take that result, goes back in, and if you check your calculator, it will indeed be this amount here, 2622. Now, from these two examples, we can see that all annuities can actually be described as a recurrence relation, and this is the general way to say it. A0, or whatever letter 0, R0, A0, is the present value of the annuity. And then to find the next calculation, you do 1 plus the rate of the annuity times the result of the previous year. And we add or subtract the value of D, where D could either be the deposit if it's a repayment, so we're plus D, or minus D if it's a repayment or a loan. So we're going to be working with this and changing annuities into a recurrence relation. So here we go. So the following, let's represent the following as a recurrence relation first, and then let's calculate 4 repetitions of the annuity. Here we go. Alyssa borrows $1,000 at 1.25% per annum, compounding yearly. And then she will repay this amount each year. So this is a a loan, and since we're borrowing $1,000, that there is our beginning amount. So let's use A. It can be any letter you like. Might make it R or M, whatever. A0 equals 1,000. Now to find the next number in the sequence, so A n plus 1, the next number, is equal to, this first part here is we are increasing by 1.25%. So firstly, 1.25%, that is 0.0125. To do an increase, we just multiply by 1.0125. So it's this number we're going to be using. It's going to be 1.0125 times a n. And then from here we subtract 257.85. This is how the annuity occurs year after year. $1,000 loan, increase it by that percentage, and then repay this amount at the end of the year. And so from here, let's now find A1. 1.0125 times the starting amount, which is 1,000, minus 257.85. Check our calculator here. 1.0125 times 1,000 minus 257.85. The value of the end of the first year is 754.65. Now to find A2, remember we take the result of the previous, so put 754.65. So 754.65. Let's just do this again. $754.65 minus 257.85. So at the end of the second year, we are left with 506.233125. And then A3, it's the same calculation. This time I'm just going to use a copy paste feature here. Now, if you remember how to do this using the calculator trick, you can go ahead and do that. But I'm going to be doing it manually using my physical calculator because it's a lot easier to type in. So 1.0125, 506.233125 minus 257.85. My next calculation gets me 254.711. Not going to write the rest. And then A4 is the same calculation, but we take the input from the previous, 254.711. In my calculator, I'm going to be using answer. Put answer in there, and I get 0.044, about 4 cents left. And that is the end of that repayment. Oops. So I hope that gave you an insight into how we can change an annuity into a recurrent relation. I'll see you in the next video where we tackle the next 3 examples. Yeah, I hope to see you then, and best of luck.